Hello everyone. In this lecture, we are going to solve all the PYQ of NEET from chapter 1 of 11th. Okay, so let's move further and stay till the end because we are going to solve every problem which has come till now. So let's start. First one is the dimension of stress. The dimension of stress, and it's in 2020 and 2022. So let's see. Stress is actually force upon area. So dimension of force is mlt to the power minus 2 upon area is L square. Then dimension of stress becomes ml minus 1 t minus, and one can remember force as F is equals to mass into acceleration, mass m, acceleration in lt minus. Okay, and area equals length to the power 2, which becomes L square. Okay, and now move on to second question. Okay, then unit of thermal conductivity. Unit of thermal conductivity comes in 2019 paper, and you have to directly remember, or you can solve from the heat flow formula, which is a small k, and the unit will become W watt meter inverse Kelvin inverse. Okay, directly you can remember this. Now move on to third question. If dimension is MA, LB, TC, okay, and the value of A is 1, B is minus 1, and C is minus 2, then the quantity is actually the question is in 2019. Actually, the question is whether pressure is right or wrong, is right or say true for this, but one can assume that like this anytime question can be asked. So let's see, m to the power 1, l to the power minus 1, and t to the power minus 2. Okay, so let's say pressure P equals force upon area, which is ml t to the power minus 2 upon l square. So rightly so, force is correct for this question. Okay, now move on to fourth question, which is the units of constant proportionality of a damping force proportional to velocity are. Damping force to velocity. Okay, so damping force is k into small b. Let's say constant k is force upon velocity. So this one becomes unit of force is kilogram meter second square, because second to the power minus 2, because force is mass into acceleration. So kilogram, if I have to calculate in SI system, kilogram meter per second square. So and velocity is meter per second square, so meter to the power minus, cut out. So this one goes to this one, and finally unit of k becomes kilogram second inverse. Now let's move on to question number 6. So 6 is maximum percentage error in x equal to x. We have to calculate the maximum percentage error in x, and the formula of x is a square b to the power 1 by 2 upon c to the power 1 by 3 and d to the power 3. Okay, and errors in a, b, and c is given as a is 1%, b is 2%, c is 3%, and d is 4%. So these types of questions are pretty common, this type of exam. So let's say if we have to calculate the percentage error, then del x over x into 100 equals, what is a? So a has power, it means 2 del a over a into 100, and you have to just write down like this. The power comes before the expression, del b over b into 100, and if division comes, then it's also in positive. So 1 by 3 del c over c into 100 plus 3 del d over d into 100. Okay, so let's put down all the values. 2 into 1 plus 1 by 2 into 2 plus 1 by 3 into 3 plus 3 into 4. So 3 to 3, 2 to 2, and it becomes 2 plus 1 plus 1 plus 12. So it comes out to be 2, 3, 4, 12, 16%. Okay, so let's move on to further. I have keep the loss of question numbering and it is 7 number. Okay, so next one is percentage error in G. Percentage error in small g, and the formula for that is S equals 1 by 2 into Z T square, and the percentage and the error in S is E1 and T is E2, and it comes out in 2008. Okay, so let's see. G is, according to this formula, Z is 2S over T square, and by calculating the percentage error we have neglected the integer number and anyhow, and del Z by del G into 100, similar to last question, del S by S into 100 plus 2 into del T over T into 100. Okay, so let's see. So it is small e1 plus 2 into small e2. That's it. Okay, now let's move on to question number 8, and that is the dimension of 1 over 4 mu naught epsilon naught. Okay, so there are two ways for doing this. One is you goes to the long route, which is you have to calculate the dimension of mu and then dimension of epsilon naught. But there is another way, by remembering a short trick, that is speed of light. Speed of light has the formula small c is equals 1 upon rho mu naught epsilon. Okay, which comes out to be 3 into 10 to the power 8 meter per second, the value of that quantity. So by using this simple trick, the dimension of this quantity is dimension of speed of light, and dimension of speed of light is similar as dimension of velocity, and it means x as dimension of velocity to the power minus 1. Okay, now let's see furthermore. I have lost track the question, so let me place it as a star. So next is, if a radius has one sphere of radius having percentage error 2%, then the error in volume, it means LV over V into 100 we have to calculate. So it is quite simple. Volume of sphere V equals 4 by 3 pi r cube. As I have previously told that no scalar quantities gives any error or dimension. That means del V over V into 100 equals, this 3 comes before the percentage error of r. Okay, so 3 into the value of percentage error, which is, so 3 into 2, 6%. Okay, let's move on to further. Or so this question is from significant figure. I'm sure you have heard this term. So let's see what is it is. The number of significant figure in 0.06900. So let's break down this. So these 20 have no significant figure, and only these parts contribute to the significant, which is 1, 2, 3, 4. So significant figure is 4. And let's say if something like this is written 0.0069, then it is only 5, because these 20 have no significance in this value. Okay, so let's move on to next question, which is the dimension of Planck constant. Wait a second. Constant similar, and it's come in 2001 and 2000. Okay, so let's see. So there is E equals h nu from Planck formula. Energy is equals to Planck constant and frequency of light, frequency of photon, or say light photon. Okay, so it has similar dimension as angular momentum. Okay, so let's see. Next is pair. We have given with a pair of work and torque. Okay, and it's coming 2013. Okay, so he asked that both of them are same dimension or not. It's true or false. Okay, so let's see. Work is forcing displacement. I'm sure you have read this formula. And torque is force into radius. Okay, so radius has the same radius has the same dimension as displacement. Displacement. It means these two have same dimensions. Okay. In P equals P naught exponential minus alpha t square. Okay. So constant, he asked constant, and alpha has dimension. Okay. So 2006. Let's see. Exponential have no dimension. It means alpha t square have no dimension. It means alpha have the dimension of 1 upon t square, which is 1 upon t to the power 2, and comes out to be t to the power minus. Okay. Now let's see next one. Dimension of 1 upon 2 epsilon naught e square. Wait, e square. Okay. So it is a quantity which is known to be energy density. So energy has the dimension same as work and energy, which is ml square t to the power minus 2. Okay. So let's see whatsoever. So energy density is energy per unit volume. So let's put it like that. Energy density is energy is ml square t to the power minus 2, as we have seen upper, and volume is equal. So that becomes ml minus 1 t to the power minus. Okay. So let's move on. Percentage error in P we have to calculate, and the formula for that is a to the power 3 b to the power 3 b to the power 2 upon under root c into d. Okay. So A has percentage error 1%, B has 3%, C has 4%, and D have 2%. Okay. So quite simple question. We have already seen the 2 or 3 questions of this type 2006, and now we'll see. So these terms comes out to be percentage error in P. I'm writing in short form. Percentage error A, 3 into percentage error in A plus 3 into percentage error in B plus 1 by 2 into percentage errors in C plus 1 by 2 into percentage error in D. Just put these values and you will find out the answer. Okay. Which is parsec is the unit of. Okay. So it comes out in 2002. So it's quite simple. Actually, parsec is unit of distance. Parsec is unit of distance. Okay. Actually, it's astronomical distance. And for the confusion, it's parsec, so someone can think that it is time, but actually it's distance, astronomical distance. Actually, we have to calculate the long distance like light years. Let's see. See, here it is. Work and energy have same unit. It's true or false? Quite old question, 1996. So it's true. We have already seen that. Now let's move on to next question. Okay. Next is solid angle subtended by a 1 centimeter area at a point 5 centimeter away. 1 centimeter square area and 5 centimeter away. Okay. Solid angle. You have to just remember the formula of solid angle, which is area upon radius square. Okay. So you can easily calculate the value. Now let's move on to the next question, and that is dimensional formula of torque. Dimensional formula of torque. So it's in 2011. Let's see. Torque is force into radius. So dimension is force ml t to the power minus 2 and radius l. So it becomes ml square t to the power minus. Okay. Now let's go. Next is dimension formula of angular momentum. 2009. Okay. 2009. So angular momentum L is mv r. Let's put this mass velocity lt minus 1 and r is l. So it becomes ml square t minus 1. Okay. Now let's move on to next question, which is dimension of gravitational constant capital Z. So one can find out F is equal to Z m1 m2 upon r square. Okay. Just put the find out the value of g, which is f r square upon m1 m2. Okay, that's the value mlt minus 2 l square upon m into m, and you will find out the dimension formula for this. Okay, now let's move on to next question, which is dimension of permittivity of free space. Dimension of permittivity of free space. Okay, so which is epsilon naught, and one can understand the formula from the Coulomb's law, which is F equals 1 upon 4 pi epsilon naught q1 q2 upon r. Just put out the values of these and you will find out the dimension. And actually dimension is epsilon naught is m l to the m to the power minus 1, l to the power minus 3, t to the power 4, and a to the power, okay, which is a is ampere, I. So let's see. Next one is unit of permittivity. Okay, it is quite interesting. Unit of permittivity. Permittivity. So it is force equals 1 upon 4 pi epsilon naught q square upon r square. Okay, so unit of this is epsilon naught is q square upon 4 pi f r square. So let's see, Coulomb square upon Newton meter square. Okay, and remember, one can ask for permeability too. Permeability, which is mu naught in free space. Okay, so you have to remember that. Next one is dimension of impulse. Dimension of impulse. So impulse is force into time. Dimension of force is ml t to the power minus 2, and time is t, so it becomes ml t to the power minus 1. Okay, now let's see. Furthermore, a measurement close to the true value is accurate. Okay, so it's a true or false question. Measurement close to true value is actually true or false. So it's true because accuracy is about how close a measurement is to the actual or accepted value. So it is true. So I hope I have covered all the questions from previous year, units and dimension. And if you have some doubts or some question, you can comment and we will try to solve it. Okay, that's it from my side. Thank you.